In this video, I am going to give you an introduction to rotational motion of a rigid body. Right? Let us begin by trying to understand what do we mean by a rigid body. A very simple definition of a rigid body is that a body, let us say this is a wall and there is an object over here. Let us say we apply force F. Now when we apply this force, the body will move and maybe touch or come in contact with this wall. And when application of force does not change the shape or size of the body, we call the body rigid body. This is a very simplistic and I would say not so accurate definition of rigid body, but for the purpose of this video that should be good enough. So rigid body is something which on application of force does not change its shape and size. That means the energy which this force is giving to this body is not used to decrease its volume, right, or increase its volume, right? It is only used to kind of accelerate the body or try to overcome the opposing forces. That is what that's a very loose definition of a rigid body, but for the time being that should be good enough. Let's move on. A rotational motion of a rigid body. In the previous videos we talked about uniform circular motion. So we use the term circular motion, whereas here you're using the word rotational motion. What's the difference between the two? When we talked about circular motion, we were talking of a body. This is the center of rotation, and the body was kind of moving in a circular path around this center. So the entire body was moving around the center, and this is what we call as circular motion. But when we have an object, for example, this very object, right? I show it over here, and the object revolves around its axis of rotation, then we call this rotational motion. So this is the axis. I'm sure you're able to imagine the axis is going perpendicular. Its axis is perpendicular to the page of this paper, and this body is revolving around that. That means all the particles in the body are revolving around this axis of rotation. Then we say that this body is performing rotational motion. So that is the essential difference between rotational motion and circular motion, right? Let's move further. So let me draw a bigger size object. Let us say this is the object, and or let me take an irregular shaped object. I think that would be more. Appropriate. So this is an irregular shaped object, and let us say this is the axis of rotation. This is the axis of rotation is perpendicular to this page of this paper, so it goes perpendicular into the page of this paper, into this page. So, and this body is, let us say, revolving in the anti-clockwise direction. So it's revolving around this in an anti-clockwise direction. That would be rotational motion. Each and every part particle of this is the center. Let me identify some. These are the particles of the body. And this is the center of the body, and all these are the particles of the body. So when this body is rotating, all the particles also move around in a circular path, right? And each of them executes a circular path. Now, we looked at angular velocity. Angular velocity is angular displacement upon time t, right? So what happens to the angular velocity of all these particles? It turns out that the angular velocity of all the particles is constant. So omega is equal to constant, right? How does this happen? Because for any particle that I take, when it moves through a certain path, right? Let us say it moves through some distance, let us say s in time t. This particular particle would also move the same distance in time t, right? Right? If they are on the same circular, right? So let us take this particular particle. Let us call it particle. A. So particle A has moved this particular distance uh, in time t. Let us take another particle which is closer. Let us in the same time t, this particle would move a lesser distance, right? Because it is closer to the circle. But the angular displacement, if I take this particular angle, right? This angle which these two objects execute would be same. That means the angular displacement would be same, and hence we say angular velocity is same. Omega is constant, even though the linear displacement is different. So v will not be constant, is not constant. But angular displacement, angular velocity would be constant. That is something which we need to keep in mind as we move ahead. Right? Okay.